Hello everyone. This is a quick review. Not review, but we're gonna be talking about Unit 8. And from Unit 8, I think the first 3 lessons that I'm gonna show you they're kind of overlapping lessons with some stuff we've already covered, and they're really straightforward because we've kind of already done them, but they involve integrals, and they may make other concepts easier to understand. Whether these will be directly tested, I'm not sure, but because they're so related to what else we're going to be doing, I think it's really, really important. So if you do get a chance to watch these, I think that's really important. Again, just the first 3 are the ones I would recommend regardless. And if you're going stir crazy, hey, something to do. That's not watch a video. Well, I guess it is watch a video, but not watch some other goofy nonsense. So anyway, we're talking about finding the perfect rectangle. So the way the video is set up, make sure you've already downloaded. Anyway, I'll give you the instructions later, but let's go. So in the past, we've used many rectangles to estimate the area under a curve. Today, we're going to try to find out the perfect rectangle. So like if I wanted to know how much area is in this space, there's got to be a rectangle, some height of a rectangle that would fit it perfectly, that would have the exact same area. So how do we find it? That's the goal, is to find that perfect rectangle that has the same area as the area under this curve. So that's always fun. So anyway, the graph of the curve shown on the interval. Explain why you think the area is more than 4 but less than 20. So I'll give you a hint. This is 4, and this whole thing, my rectangle is straight, is 20. So you write something down. I'm not going to write that one down for you. I'm not even going to break it down for you. Then it says, do you think it's more than 8, which is this, and less than 16, which is that? And in that sense, I absolutely think it's still somewhere in between. If I was going to guess an area for this, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's clearly bigger than 10, but this is almost 11, 12. That's almost there, practically. These two together maybe make another one, so 11, 12, 13, 14. But, 16, not now, then we're getting into half, so maybe 15, something around there. I mean, this is just, again, randomly guessing. So I do think it's less than 16, but more than 8, because just guessing counting the whole square shows that it is bigger than 8, and counting the pieces, I'm probably less than 16. So that's really the question. Again, find your better explanation, but those two are pretty straightforward. At what height do you think? So I think C is between 3 and 4. As I think it's somewhere bigger than 12. So this is where I think C is. So I believe, and I could be completely wrong, but I believe this is C. Now you don't need to draw the whole rectangle, just need to draw C on where you think it is. Again, I think it's between 3 and 4. Now we have 2 different methods. So C, I know, is 4 times, that one is 4 times C, because this is 4, and that's C high, whatever C is. And then the other one, an integral expression, well, they told me the name of the curve is f of x, so f of x dx, and it goes from 0 to 4. So from 0 to 4. So there's my integral expression. And if this, let's see if we can find the value of C. So we're going to go ahead and we know that 4C equal to the integral we set up, and we're going to go ahead and replace f of x with negative x squared plus 4x plus 1. So there's our antiderivative. I'm going to go ahead and get C alone. So C is equal to 1 over 4, because of the invisible 1 right here, divided by 4, times the integral from 0 to 4. Actually, let's go ahead and integrate. I don't have a lot of space here. So integrating, we're going to have negative x cubed over 3 plus 4x squared over 2 plus x, evaluated from 0 to 4. And as we go through the process and do all the work, which I have done on another piece of paper, not using a calculator, the long, annoying, arduous way, I get C. All right, so that makes C equal to 11 thirds, which is 3 3 2/3. And again, go ahead and try to see if you can get to that answer without a calculator. It's important that you do not use a calculator for any of the problems on this assignment. So how does the value C compare to all the values? And it is the average value of the function, and that's really important. Here is the average value. That's what we're trying to get at. Now, if you were to turn your paper over, the important ideas, so we all know this lovely box, and here is the picture. I'm going to talk, you're going to write, you can pause me anytime so I don't talk over you, whatever works. The average value of a continuous function f of x on the interval from a to b is the height of the rectangle that encompasses the exact same area as the area under the curve. So, and of course we know that the area under the curve is the area between the curve and the x-axis from on the indicated interval from a to b. So c times, so the 4 that we had in our problem is this b minus a, because that's how wide our interval was. So whatever is the equivalent for you there, and so that's that. Notice I've divided it 1 over in the front, and so this is the formula. This is the average value. Now what's really cool about the average value of a function that's not really listed on here that I wanted to bring up is that if let's say that this was f prime for just a second, and so we know that the integral of f prime is f, so f of x, which would be, so we've got 1 over b minus a times f of x from a to b, evaluated from a to b, and so that's 1 over b minus a times f of b minus f of a. Of course, that's 1 over. So if we multiply those fractions, we end up with the average rate of change. So now that's, of course, if we are dealing with, so one thing that can be really tricky is you can use this to find the average rate of change of the original function, not of the derivative, obviously, but of the original function. So that can be really helpful. And so that's why you kind of already know it. So just so you know why you know this already, that's the one. So again, we got some check your understanding. I am going to explain these as I do them, but do try to do them on your own without the explanation, because that's really important too. So we got Chipotle giving buy one, get one burritos on Teacher Appreciation Day. If you're willing to stand in line on a particular day, the number of people waiting in line is modeled by W of t, where t is measured in the hours since they opened. Write an integral expression that would give the average number of people waiting in line. So this here is here just to see if you recognize what's happening. So they opened at 11. From noon to 6 is from 1, because that's an hour after they opened, to 7 hours after they opened, of W of t dt. So that's the integral part. And then we're going to times by 1 over 7 minus 1. And that's equal to the average number of people. Okay? And that's really straightforward. So that's, again, one of the weird ways they ask you that question. Find the average value of the function on the interval from, so g of x dx. I was really tempted to use my calculator on this one, but you don't need to. So you've got your average value function, so 1/2, and then the integral can be broken up into 2 pieces. And I'm going to go ahead and move the whole thing over. Good. 2 pieces. 1 to 3, plus the integral from 1 to 3 of negative 4x dx. Makes it a lot easier to do the work, which is then 1/2 e to the 3x minus 3 divided by 3, evaluated from 1 to 3, minus 2x squared, evaluated from 1 to 3, which is e to the 9 minus 3 minus e to the 3 minus 3 over 3 times 1/2 in front minus 2 times 9 minus rectangle minus 2 times 9 and then 2 times 1, and that leaves me with e to the 6 minus 1 over 3 minus 16 times 1/2, which is approximately equal to 59.071. And again, you would leave it like this because you aren't using a calculator. You would not keep going. You should have stopped right here if you went that far, right there. So just something to keep in mind, especially now that the test is open-ended questions, you want to stop as soon as you are done calculusing. And calculusing does involve plugging in the numbers, but not doing the algebra that comes next. So it's good to know. Then we have our final question, and I'm running out of time on this video, so I am going to go write stuff down, pause, and then explain after it's unpaused. So go ahead and try it on your own, and then come back and watch this if you need it. All right, so to use the trapezoidal sum, I have the 1 and over 20, which was given to me, and it just sits there. And then I have 1/2 because it's trapezoids. And so you got base 1 and base 2, that's the 2 inside. And then the height, which is the distance between the x's. So this is the bases. And so you'll see there's one set, there's another set, there's another set, there's another set. And then you have the difference between these, which was 4, the difference between these, which is 5, the difference between these, which is 6, the difference between these, which is 5. And that's where I got these numbers in front. And again, I used long, hard, obnoxious, no calculator calculations to get to 62.89. But you would stop before you did that. Like once you wrote down this giant addition mess, you're done. Don't do more work. It's all good. It works out great. They know. They get really used to what they're looking for. So you're all set. Using proper units to interpret your answer, and you just recopy the whole thing. And you say degrees. I said degree units. That seems silly. I'm just using the units. Units are degrees. I don't need the degree units. So which is the average temperature of the water in the bathtub over 20 minutes. And so that's all that is. I hope that this seemed really straightforward. Average value is really straightforward. The hardest part of average value is recognizing when they're asking for average value versus average rate of change, especially because they're very, very similar. So good luck, and I'll see you soon.